Greetings from Little Rock. I hope you had a good day yesterday. I know that was a bit of a slog of a video, to be honest. It's hard to learn Arrhenius and Bronsted theory in a video. It's hard to learn it anyway, really. It's a little convoluted. So hopefully that went okay, but if it didn't, I'll help you on Monday. Today is a lot easier. It's just about nomenclature, and we're really just learning how to name acids. Now, you've already done a lot of name in my class, and so it's not too bad. There's just two classes, and it's pretty straightforward. You'll also notice that I only said naming acids, not naming acids and bases, because you already know how to name bases with one exception, because they literally just follow the rules you learned in October. But acids, they have their own set of rules. And so to start, I'm asking you to learn how to distinguish between two kinds of acids. One of them is called binary, and one of them is called oxy. And as you can tell, a binary acid is one which has hydrogen attached to an element, just two elements, one of which is hydrogen. And oxy, it contains oxygen. And that's really all we're going to learn how to name in this class. There are a few exceptions to that, but it's pretty much going to be that. So on your sheet, I've asked you to define a binary and oxy acid. And I don't remember, I may have quickly changed this around and put oxy acid down here with how to name oxy acids. But a binary acid, of course, is one which contains two elements, and one is hydrogen. And an oxy acid is literally just defined as an acid with oxygen. And remember, an acid in this class at least is pretty much going to start in H. So as long as it starts with an H, well, you're pretty much there. So that's cool, and that's really nice. And frankly, they're pretty straightforward. So now you know you have an acid, and you know it's an oxy or a binary. And you have to name it. For binary acids, it's really straightforward. Okay, so we're going to take and add a prefix. That is the thing out in front. So in this case, it's going to be hydro. And we're going to add ic to the end of the element name and put the word acid after it. It's easier to learn how to do this by just doing it. But hydro, root, ic, acid. Okay, so that's not too bad. The root, of course, is just the stem, just the base of the word. So, for instance, if I have chlorine, it's just chlor. If I have fluorine, it's just fluor. If I have iodine, it's just like iode. Right? We're just taking like the center piece of the word. And if you don't get it perfect, don't worry about it. I just wanted you to get close. So, hydro, root, ic, acid. That's how you name binary acids. How to name a binary acid is literally just going to be hydro plus root plus ic acid. So for a moment here, you're going to lose my face, and let's talk about naming three acids. This HCl, this HBr, and this HI. And I think it's easiest to see it as I just work through it. So here we go. First thing I want to do is talk about what these things are. Okay, I know they're acids because I see H, 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 right? They start with H, they're acids. I know they're binary because each one's two capital letters, two elements that start with H. And there's no oxygen in these, so I know they're binary that way too. Okay, so like on HCl, I know that this is chlorine, right? HCl is chlorine. So I'm going to take chlorine and make it its root. I'm going to add hydro to the front of it. Hydro. Chlor, and then we add ic to the end and say acid. So totally, HCl is called hydrochloric acid. Okay, well, it's chlorine. How about something like bromine? B-R-O-M-I-N-E. Okay, the first thing I'm going to do is I'm going to add the word hydro to the front. And then I'm going to get rid of the suffix, so it's just the middle. So I'm going to take the last syllable away. Hydro, brom, and then I'm going to add ic, and then acid. Cool. If you know that I is iodine, then try to name it. I'll give you like, I don't know, 30 seconds to name this really fast. So that's not too bad. 30 seconds. Starting now. Name HI. Well, maybe iodic. Maybe oh, look at that. There we are. Hydroiodic acid. And you say, well, this is really straightforward, Mr. Noack. And you're right. This isn't meant to be too hard. So hydrochloric, hydrobromic, and hydroiodic. And there aren't too many binary acids like this. They're kind of rare, but the ones that exist are very important. We work with HCl very, very commonly in my lab. HBr is pretty rare, but, we're there. Naming these isn't bad until you're tempted to use this for everything, but we'll get there. Before we get there, we need to learn how to go the other way. Work backwards. So hydrofluoric acid, right here, right? Hydrofluoric acid. Well, I see the word fluor here, right? So that's going to be fluorine, right? Fluorine. Okay, I know fluorine. On the ion sheet, fluorine is F-, right? So how many H's do I need to cancel out the F-? Well, of course, H's come in flavors of plus. So if I got a +1, -1, that's perfect. Hydrofluoric acid. Neat. Hydrophosphoric. Okay, well, I look at my ion sheet, and I see that P forms a -3 charge. And I got to get rid of all those minuses, and my H's only come in plus flavors. Uh-oh. So if I have 1 plus per H, then I need like 3 H's to cancel out these 3 minuses. So that's going to turn into, let's see, oh yeah, H3P. Okay. So we're just working backwards. And the trick with working backwards, of course, is to take a look for this stem, whatever's causing this to happen. In my experience, the oxyacids are what trip people up, and these binary acids come pretty easily. Okay, if you're stuck on this, don't fret too much. Put the word hydro in front. Even if you write hydrofluorinic acid, you're still going to get most of the points, right? And if you're like, oh, I don't know how to work backwards, make a good guess. Even if you get the charges wrong here, if you've got the right letters, you're going to get at least some partial credit, right? Don't beat yourself up is what I'm basically saying. Okay, so let's talk about what I'm doing here in Little Rock for a moment and actually look at a quick video from today so you can kind of get an idea of, well, what in the world Rockhurst looks like at one of these robotic competitions. Plus that lets us take a little mental break here for just a second. So here you're looking at where the teams actually build their robots, or at least maintain them. And most teams have like 5 or 6 people who are allowed back in these 10 by 10 spaces to fix the robot between matches, make sure things are working, to program it. And the rest of us are helping the robot out in other ways. So here's what Rockhurst Pit looked like. And you can see a pretty good picture of our robot here to see kind of what it looks like that your classmates built. So we can travel in cardinal directions, which is kind of cool. And we are mainly focused on moving around a 13-inch large kickball and putting it inside of basically basketball goals. And everything you see in this picture is just serving that. And these were all built by your classmates. No adults really touched this. So it's kind of cool to see it done that way. Alright, so let's bring it back to chemistry, and we need to talk about naming oxyacids, which honestly is only like 15% more difficult than binary acids. And honestly, if you didn't know how to name binary acids like you just learned, this would be really easy, but because you're naming acids and there's 2 different sets of rules, sometimes students can confuse them, and I'll help you untangle that in a moment. But for right now, what we're after is understanding how the general form works. So I've got a big box for you on your worksheet that says, how do you name an oxyacid? Well, here's how you name an oxyacid. You use a prefix if necessary. So this is like if you've got like perchlorate, or you have hypochlorite, or you have something that has a prefix on it already on your ion sheet, then you put it there. There's no like monoditri, any of that stuff from earlier. It's just if the name of the anion already has a prefix, you got to keep it. Then you use your root. At the end, you're going to add ate or ick, and well, we'll get there, right? Ate or ite, and that's about it. And it's either ate or ite. It can't obviously be both things. Okay. So I've taught this class a lot enough to know exactly the mistake you're going to make. You're going to tell me you have something like HNO3 and be like, I know that, that's nitric acid. But then when you go to name it, you'll write hydronitric acid. And frankly, that's dumb. You will never, ever, ever write the word hydro with an oxyacid. If you see oxygen, it is not hydro. The word hydro basically means it includes hydrogen in a binary acid. So if oxygen's in your name and you say hydro something, I'm taking half a point and I'm going to do it again and again. And it's not because it really matters that much. It just makes you sound like you don't know what you're talking about. It just, you lose the ability to communicate this. It's about naming. Unfortunately, conventions are conventions. And while naming something hydro as an oxyacid makes no sense for how we did. So on your worksheet, I've asked you with an oxyacid, you'll never write the prefix. And you might like it. You'll never write the prefix hydro, ever, and make sure you're actually getting that. Because like if you don't be careful with that, it's going to bite you in the butt. It happens every year. And it's okay, I'll correct it on your first worksheet and your first quiz and you'll learn from it. But try not to make that mistake because, well, it's annoying for you and for me. Okay, so we understand where the root comes from. It's just the same way we got it in binaries. We know more or less what the front is, so what about this 8-ite business? Okay, this is the big picture. First, you got to have oxygen. And when you do, you're going to look if it ends in 8 or ite, because on all oxygen-containing molecules on your ion sheet, they either end in, well, 8 or ite, because that's about it. So if you have 8, then it becomes ick. If it becomes ite, then it becomes us. 8, ick, ite, us. So on your worksheet, 8, well, that becomes ick, and ite becomes us. Okay. Easy enough. Let's look at this for a moment. I've got this acid here called HNO3. And I'm going to ignore the H on all of these. I'm just looking at the NO3 ion. And I'm going to come to my ion sheet, and hey, here's NO3. It's right here. It's the nitrate ion. Cool, I know that. I can work on this. Okay, so I've got nitrate, right? Nitrate. Cool. 8 becomes ick. Nitrate. Okay, 8 turns to ick. Okay, what you don't want to do is this. Obviously, that is, well, rather wrong. But 8 goes to ick. And there's no prefix because nitrate doesn't have a prefix, unlike permanganate or bisulfite. Anyway, it doesn't have a prefix that's there. So 8 became ick, and I just need to put the word acid at the end. Okay? So like NO2 on your ion sheet, instead of being nitrate, that's nitrite. Oh, hey, look. No prefix needed. No hydro for certain. Nitrite. Ite becomes us. So instead of nitric acid, I have nitrous acid. And, you know, if I could spell instead of doing robotics all day, it would be helpful. So I've got nitrous acid. You're good. All right. So I don't think that's too bad. And the only thing we have to do now is learn how to go the other way. So what we're going to do here is first figure out the root. So when I'm looking at this, I'm looking for anything that isn't ick or us. So I see things that aren't ick here. I see things that aren't us here. Easy enough. Let's start with perchloric. So I'm going to go down my anions until I find something that looks like the word perchlor. Perchlor. Acetate, no. Bromide, no. Here we are. Perchlorate. Okay, cool. I know that perchlorate is related to perchloric acid because 8 went to ick. So if I've got perchloric acid, it had to start with the perchlorate ion, the ClO4 minus ion. And once I know what I have here, I know I just need to ask how many hydrogens, because remember acids make hydrogens, how many hydrogens are needed to cancel out that minus? Well, perchloric acid must have 1 hydrogen because I got to get rid of 1 minus. So I get HClO4. Okay. So I'm going to look for something that's sulfur, us is ite, right? So I'm going to get like sulfite. And sulfurous is a little weird because you would think it's just going to be sulfurous, but you don't have a good way in English to make the word sulfus, so there's this UR added. And again, you don't know that, and that's fine. We know we're going to look for an acid that's based on the sulfite ion. So we're going to find sulfite. Hey, here we are, sulfite, SO3 2-. Easy enough. So the sulfate ion is SO4, and the sulfite ion is SO3 2-. So I got to ask the question, how many hydrogens do I need to cancel out 2 2-? Well, okay, that's easy enough. Each H is a plus, so if I want to get rid of 2 minuses, I need 2 pluses. So I'm going to write it H2SO3. Okay, I feel really good about this. It's not too bad. Actually, it's more than not too bad. It's basically straightforward. So if I've got these things, you probably think I'm going to have to go through all the naming the bases, but you already know how to do that. It's literally the same way you normally name things. Right? If you have NaOH, it's just going to be sodium hydroxide. If you have SROH, it's going to be strontium hydroxide. Right? If it's got hydroxide, it's just going to be a hydroxide salt, so it's just going to be the name of the cation, the positive, plus hydroxide. Right? Because bases contain hydroxide. There's only one exception for my class that I care about. The only thing I care about, the only mistake, and I would write this down on your sheet in like big box letter with a star next to it that says, learn this and memorize it. It's that simple. This is going to be on your test. It is going to be on your final. It's too common and too important not to be. The only base that you don't name normally, which means the thing I am guaranteeing you I will ask about, is ammonia. NH3 is not nitrogen trihydrate in my class. I understand that's a proper name. I agree. But as a base, we're going to call it ammonia because, let's face it, you can go to the store and buy ammonia. When you talk about ammonia, that's what we know. It's too common of a chemical in real life that you have to know what it is. So on your sheet, someone write down in a big box, NH3 equals ammonia because, well, it does. If it doesn't equal ammonia, I'm going to take off points. And I guarantee you the first time you see me in a quiz, the first time you see it on the test, I'm going to ask, what is the name of ammonia? What is the name of ammonia? What is the formula for ammonia? What is NH3? It's going to show up because it's the only base I can ask a question about that isn't just normally named. Okay, very quickly, looking at your homework. I am asking you to name 8 chemicals here, either acids or bases. So like I've got an acid here, an OH that's a base. This one doesn't look like an acid or a base to me. Wait a minute, Nick, what are you talking about? I thought you had to be. But if you think about it, this doesn't start with H, so it has to be a base. So you just name it like a salt. And down here, you just name it exactly how you would. If you see the word acid, it's an acid. And if you see the word not an acid, like hydroxide or carbonate, it's a base. So I want you to give these a try. I want you to give them your best effort. Get where you think is right. You've got the rest of the period to do it. It will not take you that long to do 16 of these. You'll probably finish with enough time to work on something else. You shouldn't have homework this weekend. And on Monday, I'll check these with you. Until then, thanks for putting up with a couple of videos, especially in kind of this looser format. And I look forward to seeing you on Monday and letting you know how we did at this competition. Have a great weekend. Ciao.